Hi, I'm Imershein, a Principal Product Manager at Red Hat, and I'm going to speak with you today about monitoring SQL Server on Linux performance with Performance Copilot in Grafana. For our agenda today, we're going to talk about the SQL Server on Linux Platform Abstraction Layer, or SQL PAL. And really, the SQL PAL is used on Windows as well. It's a very good idea to understand how it impacts performance and the way that you view performance in a Linux environment. Then we're going to give you an introduction to Linux performance tools. After covering that intro, I'm going to deep dive into a couple of very popular sets of those tools. The first is the BCC tools, which give you near real-time performance information out of the Linux kernel. And the second set of tools are the Performance Copilot, or PCP tools. And we'll talk about why those are important later on. I'm then going to demonstrate PCP and Grafana, which is a graphical way to visualize metrics with SQL Server. I'll identify some problems with you, and then I'll show you what you can do about them by tuning SQL Server on Linux. I mentioned before I wanted to talk about the SQL Platform Abstraction Layer, or SQL PAL. And for SQL Server on Linux, there are really three things that you need to know. The first is that most of the operations run the same platform assembly code, whether you're on Linux or Windows. So you're not really going to see a whole lot of optimization around that code, whether you're running on one platform or the other. However, that being said, if there is a performance advantage to Linux, SQL Server has been modified to take advantage of it. And Microsoft continues to make additional modifications all the time. So SQL Server on Linux performance has changed dramatically over the last 4 years since SQL Server on Linux was first launched. And I'm going to show you later on how you can tune Linux and SQL Server to really take advantage of some of those performance capabilities. Lastly, I want to mention that all resources in a process are managed by SQL PAL. This means every memory allocation and thread is controlled in the same way across all the supported platforms. That includes Windows, that includes Linux, and that includes the Mac. And so that means that many of the performance counters that you're used to accessing through SQL Server, you'll be able to access even with SQL Server on Linux to get information that's coming out of that SQL PAL, even though that information is on a Linux platform. And we'll see some examples of that later. It is worth mentioning that SQL Server on Linux does have some performance features that are not available on other platforms. A big one of those is support for production container platforms. And these include CRI-O, which is the underlying container platform for Red Hat OpenShift, Docker, which you're probably familiar with, as well as Podman, which is available on many Linux distributions and gives you a way to run containers without running as a super user or root. And you can also choose the types of images that you want to run, the actual containers themselves. So there are containers that are based on the universal base image, which is derived from Red Hat Enterprise Linux. And then there are containers that are based on Ubuntu images. And you can choose which work best in your environment. It is worth mentioning that containers have much less overhead than virtual machines. So you can generally run more SQL Server containers in a single instance than you can if you're using a virtual machine environment. This is especially true on bare metal, but also even running in the virtual machines in your cloud provider, you can take advantage of containers to get more density out of the virtual machines that you're being issued, and take advantage of the fact that these containers are licensed by Microsoft using the virtual machine model of licensing. So there's some cost savings to be had there as well. The other feature that I should mention is SQL Server on Linux does support Enlighten mode for Intel Optane DC persistent memory. So if you're using Intel persistent memory features, you will be able to take advantage of them more effectively on a Linux environment than on a Windows one. And specifically, Enlighten mode allows you to accelerate writes with Optane memory rather than just reads, which you can do on Windows as well using the hybrid buffer pool. oh my gosh, this is Linux. It's scary, right? I wanted to point out that it's not magic. Linux isn't magic. It's just different. And what do I mean by that? Well, of course, there are different performance monitoring tools. You're not just going to plug into perfmon and get all the performance data that you need. There are different ways to tune the system, and we're going to cover some of those. There's different hardware supported and different ways to use the hardware. We talked a little about that earlier. And there are different ways to integrate in with Active Directory, high availability, etc., which are, I'm sure, are the topics of other talks being given at the session. But if not, I've certainly blogged on all of these topics. First thing I want to dive into is really these performance monitoring tools of Linux. And the sheer number of tools can be overwhelming. These are really just a few of the performance monitoring choices that you have available. And so even some of these, like PCP and BCC tools, are really entire suites of performance tools. But there are some that are really important to understand. The first one is top. And this is a way to provide you with a dynamic view of the processes on a running system. You can sort those processes by CPU utilization, or you can sort them by memory utilization, and that can be extremely useful. It's being updated periodically, and it's going to display a variety of information, including a system summary and a list of tasks currently being managed by the Linux kernel. The second tool that's really important is PS. And just as top is giving you an updated view into the performance of the system by looking at individual processes, PS is giving a point-in-time view of a select group of active processes that you can choose when you execute the command. The third command that I wanted to talk about is vmstat. And this is really designed to give you instant reports of your system's process, memory, paging, block, I/O, interrupts, and CPU activity. So there's a lot of information you can get here, and you can get that information in intervals that you specify on the command line. Then there's also SAR, which is a very traditional utility coming from System 5 Unix, which allows you to collect and report on information about system activity that's occurred so far in the current day. Now, all of the utilities that I've talked about so far really come from the Unix environment and were brought over to Linux as Linux evolved in the 1990s. Most of these tools were widely used in the 1980s, so they've been around forever. They're well understood and well documented on the internet. But there are two newer tool suites that I want to talk about today. And one of those is BCC tools, which is a tool set that allows you to figure out what's going on in the kernel and see what's going wrong or not working as expected. And the other tool set is the PCP, or Performance Copilot tool set, which is a suite of tools, services, and libraries for monitoring, visualizing, storing, and analyzing system-level performance measurements. We're going to dive into both of these a little bit more now. First up is BCC tools. Now, it's important to understand that the BCC tools are powered by the extended Berkeley packet filter. And this is running essentially as a virtual environment within the Linux kernel itself. And this allows you to get immediate insight into system performance. You can figure out what's wrong or not working, as I mentioned before. You'll get a dynamic kernel tracing without having to reboot the system. And you can reduce the time and overhead for each trace point. We're going to do a live demo now of that.
So in this lab, we're going to take a look at the BCC tools set. I'll show you how to install the BCC tools, use the BPF tool to show which tools are running, and run trivial tracing tools to get familiar with the whole concept. So what we're doing here is we are installing the kernel development package, which is needed to hook in the BCC tools directly into the Linux kernel. You'll notice that I'm using the uname-r command here. That just gives us the release number of the Linux kernel so that we're sure we're installing the right package. So it's worth mentioning while this install is going on, eBPF is this in-kernel virtual machine that allows code execution in the kernel space in a restricted sandbox environment. with access to a limited set of functions. That virtual machine is able to execute special assembly-like code, and the code is then loaded into the kernel and translated to native machine code with just-in-time compilation. All of the BCC tools that we're looking at today are using eBPF. I'm going to now list the tools that are on this system. We've got to look at only the files that got installed that go into user share BCC tools, because that's where all the tools live. All right, and now we can see just how many tools are here using the word count command. It says 238 tools. So that's a lot of tools. We're not going to cover them all today. Instead, what we're going to do is we're going to run some of the tools, and then we're going to go do a system update, which of course is a good workload because it writes a lot of data onto the system, and we can get an idea of what's going on and how these tools can help you to understand how the system's being used. We do need to install the BPF tool, which will tell us which tools are actually running. And command bpf tool prog list will list the tools, and you can see none are running. But now we're going to start kicking off some of these tools, and the first tool we're going to kick off is the get host latency tool. So now we're going to be running this tool. Of course, we don't really have anything going on at the moment. Now we're going to do the TCP life tool, and this is going to show you about established TCP connections. So we'll go ahead and kick this one off. Okay, and again, we're not really running anything yet. We'll go ahead and run the file top tool. I should mention I'm doing this all on different virtual screens. All of these tools continue to run after you execute the tool until you exit out by using the interrupt command or Control C. So they're constantly collecting information. So I needed to have a terminal to run the system update while I do this, and then I can show you some of the output of the tools. Okay, so this tool, the file top tool, will show you every second which files are being used in the system. So in terms of reads, writes, and the amount of data being written and read. The next command we're going to look at is XFS lower. And this command is going to look for our file system operations that are slower than 10 milliseconds. Now, we're on a quiet system right now. We're not going to see anything come out of here initially. The last one we're going to look at is called cache stat, and it'll actually look at cache hits and misses on the system. All right, so now our tools are running, and if you recall, we did install the BPF tool, and so we're going to do this again. We're going to run BPF tool program list. Okay, and you'll see, so this shows you all the BPF programs presently loaded. Now we're set up with several eBPF observability tools running, and in the next step, we'll begin observing the yum update sample workload. So, first thing we're going to do, a yum update, which is the system update command on Red Hat Linux. And as we kick this off, I'm going to go to the get host latency. And what you see is yum looking at IP addresses for localhost and for subscription.rsm.redhat.com, as well as cdn.redhat.com, because it's going to download files from there. If you look at the cache stat command, you're going to see you're operating entirely on system cache and not having to retrieve data from storage at this point in the operation. And again, if you look at the TCP life command, The output shows that yums establish a connection to port 443, and as well as the IP address that we're hooked into. And if you look further, according to the sample output, the connection lasts for over 6,000 milliseconds, right? So now yums began installing the updates. If we go look over here, we can see that. Okay. And if we go to the file top command, you can see in the type command that these are all regular files. That's what the R means under the T above. Further, you can see the counters in the reads column report greater than 0. And this shows you in real time what yum is doing with files on the system. And then let's go to XFS lower. And you start to see XFS operations taking longer than 10 millisecond threshold. Because remember, this is only looking at 10 milliseconds. And the disk operations start to get displayed. Finally, let's look at the cache stat command. And before, you saw a lot of zeros among the cache, but now you're seeing a lot of misses. So before you were seeing a lot of hits, now you're seeing a lot of misses. And if you keep watching the cache stat terminal, you'll notice that number of misses goes back down to 0. And this is because, obviously, at some point, yum update is going to be finished. I've sort of time-lapsed it for you, but you can see the updates are all completed, and now we're no longer seeing any cache hits.
So, in addition to BCC tools, we also want to discuss Performance Copilot, which is in itself a toolkit for in-depth performance analysis. With the PCP toolkit, you can manage performance data in real time. In fact, the PCP kit interfaces in with BCC tools itself. So these tools, actually, many of them can leverage the BCC tools that we're talking about. We can leverage logs of historical data for comprehensive analysis of patterns. We can compare live results with archive data in a centralized location. And we can visualize, store, and analyze system-level measurements. Well, let's take a look at how all of this can work with SQL Server. So in this lab, I'm going to show you how to install Performance Copilot, or PCP, on Linux. And again, we're using Red Hat Enterprise Linux, so there may be some differences on different distributions, but Performance Copilot is available for all of them. I'll show you how to analyze a critical system resource using PCP. We'll install the PMDA for SQL Server, the Performance Metric Domain Agent. And we're going to analyze SQL Server performance by running a sample column store-based analytic query using SQL Server. Now, PCP has a lot of front ends, some command line, some graphical, and some web-based. But for this lab, we're going to focus on the command line so you can see what's going on behind the scenes. Then in a later demo, I'll show you how to hook all this into Grafana so you can manage it through a web interface. I also wanted to mention that this lab is available for you to try yourself, and we'll be sharing the link to the BCC tools and PCP labs at the end of the presentation. Since this is an introductory PCP lab, our setup is going to consist of a single node system running PCP. Now we've set up 2 terminal windows running on the local machine. The current terminal window gets used for OS-specific commands and to interact with SQL Server, while the PCP terminal, here we go, will be used for running PCP-specific commands and for looking at the output. So to start with, let's confirm that SQL Server is installed on this system, and we'll use the system control command to do that. And the name of the SQL Server service running on Linux is mssql-server.service, and we can see that it's running. So now we can go ahead and install the PCP packages on Red Hat Enterprise Linux. You do that using the yum command. Zeroconf package will bring in a bunch of different PCP packages, as well as choose a default same configuration for them. So I'm going to go ahead and use that. And once we're done here, we're going to start the PMCD, or PCP collector daemon, and we're going to tell it to start collecting system performance data. Then we're going to enable the PMCD, and that will make sure that it starts every time the system comes up.
And lastly, we'll make sure that the service actually is running using the system control status command, similar to the one that we just used for SQL Server. So first we're going to start the PCP collector daemon. Okay, here's the start. And now we'll go ahead and we'll enable it. Okay, and then we can check on its status. And there it is, it's up and running. So now let's go ahead and inspect the PCP configuration of this particular system and see what's currently configured for PCP. And to do that, we'll use the PCP command. Now this output shows two main underlying components of PCP. The collector daemon, PMCD, which organizes, collects, and manages metric information, and the performance metric domain agents, or PMDAs, which know how to gather information for different services. The file paths for PM logger are there, which archives logs of performance metric values, and the PMIE, or interface engine, for performance metrics. That log file is also shown. Now PCP can collect and show a host of different system kernel metrics, but for this particular example, we're going to take a look at all of the ones that are available. To do that, we'll use the pminfo command. And you can see a whole list of metrics. I'm going to clear the screen now. And we're going to take a look specifically at one of these metrics. To do this, we'll use the pmval command. And we're going to use a command that will report on idle processor utilization for each CPU on the host every 1 second in a 5-second window. And every 1 second, we will collect these over a 5-second window. So that means it'll stop after 5 seconds. And we're going to look at the kernel.per.cpu.idle command. Now, if I had used the -H option, I could have specified reports on a different host instead of on the local host. But by default, we're looking at the local host that we're actually running this command on. So it is important to remember that the PCP utilities are client-server in nature and that you can use them on remote systems. Now later on, we're going to use the same pmval tool to monitor SQL Server performance. But first, we need to install a PMDA for Microsoft SQL Server. The PMDA for Microsoft SQL Server is called pcp-pmda-msql. And we're going to use the -y command so we don't have to answer any prompts while we're doing this. Once this is installed, we're going to have to create a new user for SQL Server so that it can be used by PCP. And I've actually got a script here. Let me just clear the screen again and we'll list out what scripts I have. I've got a script here called create_user.sql. And that script is going to create a SQL user with read-only access to performance information. So you can see that here. We're going to go ahead and use our friend SQL command to run that script. This is pretty similar to the command that you would use to do this on Windows. Okay, didn't see any issues there. Now we need to go and take a look at the actual PMDA configuration for MS SQL, because we're going to have to tell that PMDA about our account that we just set up. So we're going to cd into var lib pcp PMDAs MS SQL. We're going to take a look at the mssql.conf file. And here we see the username for SA is the default, and there's a default password in there. But neither of those are really going to cut it for us, so we're going to go ahead and change them. So let's go ahead and go into the file, and we'll make our modifications. Here we are. And
login. Okay. And now we're going to use Red Hat 1. And that's got an exclamation point in it. And at this point, we'll write file and quit. Now we do want to make sure we can look at the permissions of the mssql.conf file. That file now has a password in it, so we want to keep it secure. In order to do so, we need to make sure that it is only readable by the root user. And you do that with the chmod 400 command. So this is a read-only by the root user only file. And now that all of that is done, we can go ahead and install the SQL Server PMDA. And to do that, we just need to run the /install command from within the directory. Okay, the SQL Server metric should have appeared. There should be 168 metrics and 598 values. Let's go ahead and take a look at those various metrics that are available. There we go. Okay, so we see over 150 metrics tracked across different SQL Server resources that PCP can capture. So now let's run an aggregation SQL query using SQL command as a background task. And we'll monitor the SQL wait statistics using the pmval command in PCP over a 10-second window. Of course, wait statistics are one of the most important indicators to identify performance issues in SQL Server. So here's our command. Go ahead and run this. The results give administrators a good indication of where the problem might exist. For example, a higher CX packet weight value might indicate contention due to thread parallelism, and it might require adjusting the degree of parallelism in SQL Server. So we've talked a little about BCC tools, and then we talked about PCP. The next thing I want to discuss is Grafana, which is a web-based open source solution for displaying and monitoring performance, customizable metrics, and trends. Grafana connects to a variety of data sources, including PCP, and it can actually also hook directly into SQL Server, and you can grab your performance counters directly using T-SQL calls as well. So you have a number of options there. An advantage of using PCP is that it already collects all these counters for you, and it does it in a way that is friendly to SQL Server without the queries overloading SQL Server. Now let's look at a demo of PCP and Grafana with SQL Server. So Grafana is a really popular open source analytics and monitoring interface. And with SQL Server, we can use it to visualize metrics collected by PCP. Grafana can be configured to show metrics over a specific time range, and the metrics can be exported if you want to your favorite spreadsheet. Grafana also comes ready to handle several data sources. And the PCP Grafana integration provides vector, Redis, and BPF trace as data sources. That last one ties into the BPF tools that we looked at earlier. These integrations also bring several pre-configured dashboards, or they allow you to customize your own dashboard based on a particular use case. But today we're going to look specifically at the SQL Server dashboard. PCP's had support for SQL Server metrics for over a year now, and I already gave you a demo of how to set that up on a Linux system. But you do need to perform an extra step to use it with Grafana, and that is you need to start and enable the PM proxy service. So the first thing we need to do is we need to enable the PM proxy service. And then we'll have to start it. There we go. So system control enable, PM proxy, and then system control start. Okay, it should be up and running now. And the next thing we need to do, if you're running a firewall on your system like I am, you'll need also to make sure that PM proxy is added as a service to the firewall. So we'll do that with the firewall command That's firewall-cmd. We add the service PM proxy and we want to make it permanent. There we go. And now we need to reload our firewall rules because we've just changed them. Here we go. All right. Now we're ready to install Grafana. And we'll do that. Since we're on Red Hat Enterprise Linux, we'll use yum to install both Grafana and Grafana PCP. Alright, so Grafana and Grafana PCP are installed, and as with the PM proxy command, we're going to need to start the service, and we're going to want to open the firewall for the service. So we'll just go ahead and do the system control again, but this time we're going to enable Grafana-server. Okay, and then we'll start Grafana-server. And finally, we'll go in with the firewall command, and we will add the Grafana service. Okay, and once again reload. I should mention at this point that everything we've done up to now can be done just by editing a configuration file and running a single command on Red Hat Enterprise Linux. That's using Red Hat's performance metrics system role for Ansible. I did all this from the command line because this isn't just about Red Hat Enterprise Linux. It's also about the other supported SQL Server on Linux distributions. Anyhow, now that we've configured Grafana, we can launch a browser and go to my host. And we're going to connect on port 3000. There we go. And the default username and password is admin. It will prompt us to change it. Please do so. So we're going to set our new password to something more complicated. And there we go. So at this point, we're going to click on the configuration cog of Grafana. And we're going to select plugins. And under plugins, we'll search for the Performance Copilot plugin. Okay. And we're going to enable that plugin. And this time we're going to click on Data Sources. And we're going to add a data source. The data source we're going to add is PCP vector. So we'll go ahead and choose the PCP vector source. We need to give a URL here, which will just take the default of http://localhost. And then I think the port was 44322. And then at the bottom of the form, we'll click Save and Test. We can see that the data source is working using Performance Copilot. So now let's enable the Microsoft SQL Server dashboard. And to do that, once again, we're going to go to Data Sources and PCP Vector, Dashboards, and we're going to import the Microsoft SQL Server dashboard. So now let's go ahead and double click on the Microsoft SQL Server dashboard, and we'll move into it. We see there's no data because we're just starting to collect the data now. And here we go. Now we're starting to see some data. So after you bring up this dashboard, here's some things you can do with it. For starters, I recommend you start by looking at CPU and memory metrics. Looking at the Linux run queue, you can see here the system percentage of CPU and the CPU utilization metrics, which are done for user and kernel space. And you'll see that these are looking at multiple cores rather than just at the processor as a whole, similar to perfmon. If your CPUs are highly saturated, it's time to start looking at the processes on the system using command-line tools like pcpa-top to identify processes hogging CPU or memory on the system. So going back to a terminal, here's an example of how to use the pcpa-top command. Now remember before I said that top could be used to take a look at memory overhead. To do that, you simply press capital M after running the command. And now what you'll see is the process that's consuming the most memory on the system will show up. In this case, it's SQL Server, and that's a good thing because we would expect SQL Server to be using the most memory on the system. If it were something else, I would be concerned. So from a SQL Server perspective, the wait statistics are pretty important to help you track down CPU and memory utilization issues. For example, a high number of SOS scheduler yield or thread pool might indicate that your workload needs additional processing resources. Similarly, the SQL Server Memory Manager metrics can help you identify how much memory SQL Server is working with overall, as well as how much memory is being stolen for purposes other than the SQL Server page cache. So similarly, SQL Server Memory Manager metrics can help you identify how much memory SQL Server is working with overall, as well as how much memory is being stolen for purposes other than the SQL page cache. An unusually high number for stolen memory indicates memory pressure in the database system, and fixing it might require a change either to how SQL Server is utilizing its memory or increasing the amount of memory provided to the OS. Of course, memory problems can also trigger disk problems, so we need to investigate this area next. Without enough memory, disk activity can rapidly increase because we're paging memory out to disk, or swapping. You'll have already determined whether you're swapping if you've gone to use the pcpa-top command, as I talked about before. But probably the most interesting thing you can look at with disk utilization is whether you're running out of throughput or IOPS. And you can see we provide both throughput and IOPS data on the dashboard. You can do some basic testing to confirm the maximum capability of your devices. For this, there's a tool on the command line called FIO, which you can use to generate synthetic workloads for disk. And if you know the max throughput and max input-output operations per second for your devices, you can use that knowledge to determine when to add more storage through RAID, move to faster storage, add caching to fast storage tiers, or when to split up your data stores. SQL statistics can also help you understand storage contention issues. For example, you can look at the SQL OS wait stats and determine the page.io latch metric. Some number of waits for SQL Server is typically acceptable, but an order of magnitude difference in this statistic versus other wait types might indicate a problem that needs fixing by moving to faster storage. That said, there's also the possibility you have a database tuning problem, such as a poorly designed index that's spiking up disk I/O. The dashboard tries to present SQL Server stats that are interesting at a glance, but that doesn't mean you don't need to baseline your environment for those statistics to understand a definition of normal. Now let's take a look at some ways that you can tune the system to improve SQL Server performance. All this Grafana data is great, but what can I do with it? Right? Well, here's an example of a system that I tuned using GCP and Grafana with SQL Server on RHEL, Red Hat Enterprise Linux. And here's an example of after doing the tuning. I used the tproc performance benchmark from HammerDB 4.1 to collect this data. And I used SQL Server 2019 CU10 running on RHEL 8.4 under a KVM virtual machine for each of these tests. But you can see I got a lot of performance by tuning SQL Server on RHEL. When I did that, the first thing I did was run the SQL Server PCP Grafana dashboard that I just showed you. And I took the default configuration having just installed SQL Server. My tuned profile, because I was running on a virtual machine, defaulted to virtual guest. My SQL Server on Linux always defaults to the control alternate write through data path. And You can see some of the resource consumption here. I know it's hard to see the screen, so I captured some of these numbers here. My CPU busy is approximately 20%, and my per CPU busy on the system is about 6%. And the average disk IOPS was about 3K. Well, we're running in a virtual machine. It's understandable on a laptop. But then I went ahead and did some tuning. And I changed my TuneD profile to use the Microsoft SQL TuneD provided by Red Hat. I also changed the write path mechanism used by MS SQL. So we set the control write through flag to true and unset the alternate write through flag. And we set trace flag 3979, which is very important because this allows SQL Server to take advantage of the force unit access capabilities on the XFS file system. I should mention that while Red Hat Enterprise Linux defaults to using the XFS file systems, other Linuxes may not, but I strongly recommend, whether you're using SUSE or Ubuntu, that you do use XFS, because if you use XFS, you can take advantage of this trace flag. And what you see here is a very different picture. You'll notice, for example, all of this color is different CPUs peaking up at various times. And you'll see our CPU utilization jumped approximately 40% for CPU time and user space, which is where most of SQL Server's time is spent. And even our system time increased substantially to 7.5%. Again, looking at that color, that shows different CPU cores were able to run more information, and we're getting better scheduling. So look for color in that graph. You'll also see that our IOPS improved as well. And again, this is from using trace flag 3979 and the control write through option.
So I didn't want to leave you without a good understanding of how to actually make the changes that I just discussed. So we'll go ahead and we'll make them now. To start off, we need to use the TuneD ADM utility, which will allow us to set the TuneD profile for SQL Server. So let's go ahead and look at what the current active TuneD profile is set to with TuneD-ADM active. And we can say it's set to virtual guest. But we're going to change it, and we're going to reset it to MS SQL. There we go. We're now using the MS SQL TuneD profile. At this point, we're going to set the support for trace flag 3979, and we will also set the write cache mode. So let's start off by setting the trace flag. So to do that, on Linux you use the opt msql bin msql-conf command, and we're going to use it to set trace flag 3979 to on. Okay, now we're going to want to set the cache for FUA support to the right mode. And to do that, again, we'll use the msql-conf command. So now we're going to go ahead and enable the proper cache mode to take advantage of trace flag 3979. We'll use the write-through mode, and we're going to set that to true. There we go. But we also need to disable the alternate write-through cache. So there we go. Now you'll notice it told me that I need to restart the MS SQL Server service, and we'll go ahead and do that now. And there we go.
To learn more, I really recommend you look at Microsoft's best practices for SQL Server on Linux performance. And this is a great document. It covers all three flavors of Linux that Microsoft supports. The performance tweaks for all of them are provided. I also recommend that you look at Red Hat's SQL Server on Linux performance blogs, many of which I've authored. And finally, I recommend you look at Red Hat's SQL Server on Linux labs, which will walk you through performing some of these operations that I've just shown you using SQL Server on Linux. I want to say special thanks to Microsoft for supporting the Data Platform Geeks and SQL Server Geeks community initiatives. And I want to thank all of you and remind you that there are 3 ways to win prizes this week. Post your selfie with the hashtag DPS2021 during a session, give session and conference feedback, and visit, of course, the sponsors and exhibitors who make this all possible. Finally, follow the Data Platform Geeks and the Data AI Summit on Twitter. I'm Louis Imershein. Have a great day.